So we're going to start with the box method for distributing polynomials, and what we're going to start with first is two binomials. So remember, binomials are the number of terms, and there's two terms. So here I have x plus 4, so there's one binomial, and then I have x plus 2, so there's my second binomial. So to complete the box method, I need to do x times x to fill in this box, and when we do that, we have x squared, because remember we add the exponents. And then again, I'm going to drop down this x times the 2, so I'm going to get 2x. And then I'm going to slide this guy over, and I'm going to bring this guy down, so that's x times 4, so that's 4x, because we always write the number first. And then last but not least, I'm going to do this 4 times this 2 to get 8. So we just fill in the boxes like a multiplication chart. I've heard some of you call it lattice before. Similar idea. But if you look, you always want to look on your diagonals, really just throughout any of the boxes, and see if you have like terms, which we do. So we add those like terms together, which would be 6x. So then from there, we list out all of our terms, and we get from standard form, x squared plus 6x, the two that we combined, and then we have plus 8. So we're going to go ahead and try another one. So we have x plus 3 and x plus 5. So again, it doesn't matter if you put x plus 3 on the top or over on the side, just as long as it's present, and vice versa for the x plus 5. So we fill in the first box, x times x is x squared. And then we have x times 3, the number goes first, then the letter, and then we have x times 5, so we get 5x, and then last but not least we have 5 times 3, which is 15. So again, we want to combine like terms. So x squared doesn't have anything to combine it with, so we just have x squared. And then we have an x here and an x here, so we combine this. A lot of times it is a diagonal, so we combine them. So 3 plus 5 is 8, so plus 8x. And remember, we don't change the exponent at all when we combine them. Only when we multiply are we going to change the exponent. And then last but not least, we've got this 15 here, and we just tack that guy on at the end. So I want you to pause the video really quick, and I want you to try this one out on your own. Remember, watch your signs because you have a negative this time. So we've got x times x, x squared, x times 4, 4x, x times negative 3, negative 3x, and negative 3 times 4 is a negative 12. I got a feeling some of you put a positive 12 there. So again, x squared is by itself. And we've got 4x and negative 3x. So we're going to combine those like terms. So yeah, we'll add them, but it's 4 minus 3, which is a positive 1. You don't have to write it, so we can just leave x. You can put 1x, up to you. And then whatever we have left over, because we can't combine it with anything, and there we go. That's it. So again, try this next problem on your own, and then pause the video, and then when you're ready, play the video to see the answer. And this is a minus 7 back here. So we get x squared, x, negative 7x, and then we get negative 7. So again, we're going to combine x squared minus 6x minus 7. So that's it. And then I believe we have one more. So again, go ahead and try it, pause it, try it on your own, and then we'll come back together. X minus 2, 2x minus 6. 2 times 1 is just 2. X times x is x squared. X times negative 6, negative 6x. Negative 2 times 2 is negative 4x. A lot of people drop this first 2, so be careful. Negative 2 times negative 6 is a positive 12. It helps to put the signs in, go for it. It's not hurting anything. So again, combine like terms. We write it all out. So we've got this 2x squared. Our like terms makes a negative 10x. And then we have our last but not least, positive 12. Now, if you wanted to try this by chance with a binomial, so let's just say x plus 1, with a trinomial, so 3 terms. So let's say I had x squared minus 2x plus 3. We're going to just do the same exact thing. We'll do x plus 1 on the side. Just create your own box. And then we put our other terms on the top. X squared minus 2x plus 3. X squared times x, so again, 1 and 2 makes 3, so x cubed. And then we have x squared times 1, so that's just x squared. Then we've got x times negative 2x, so again, this one has a 1, so we add those exponents, so x squared, but don't forget the coefficient out front. And then negative 2 times 1, negative 2x. And then we've got 3 times x, so 3x, and then we got 3 times 1 is 3. So again, combining like terms, this is where it gets more difficult. So here's what I like to think of. We have a binomial times a trinomial. So what is 2 times 3? Well, it's 6. So did I get 6 boxes here filled in? Sure did. But that doesn't mean it's your final answer. Your final answer, you always have to look to see if you can reduce it as much as possible and combine as many like terms as possible. So I'm going to look through it. Do I have any other cube terms? Not there, not there, not there, not there, not there. So we're going to write that guy down for our solution. Now I'm going to look for all the squared terms. Well, here's a squared term, here's a squared term, nothing, nothing, nothing. So 1 minus 2 is a negative 1 squared, x squared, sorry. So those are good. Now I've got a negative 2x. Here's another x term. This one doesn't have anything, so we combine those. So negative 2 plus 3 is a positive 1. And then last but not least, this guy's on its own, so we just tack it on at the end. So that's it. You just simplify it. So even though we filled in 6 boxes, it doesn't mean that we're going to have 6 terms at the end. So go ahead and try what I have posted for you, and we'll see you tomorrow.